Hey all, this is Mr. Yeager for Physical Science, finishing up the section on solutions. So we're going to be focusing on the property of solubility of a solution. We're going to be looking at some solubility curves and giving some basically more descriptions of solutions. So it's a bit of terminology we want to handle. So we got the basic definition of solubility right here. Solubility is the measurement of how much can be dissolved, and this is at specific temperatures. So we had gone over in the prior video how we can affect the rate at which something's dissolved by stirring, by surface area, and by the temperature. We're going to get a little more detail now how temperature can kind of help along having more and more get dissolved. Not just how quickly it dissolves, but how much you dissolve. All right, so solubility is a measurement. Basically, we measure it in essentially like grams per milliliter, where it looks like milliliters of water. It almost looks like a density calculation, but we're not actually going to do any calculation for it. Okay, so there's that. There's three terms we use with solubility, basically describing the solution. We either say, first one would be that the solution is saturated, so a saturated solution. What this basically means is that we have the maximum amount dissolved in that solution. Okay? Now, how can I tell that I've reached the maximum amount? I mean, that's the thing. We can sit there and be like, oh, that solution is saturated and stuff like that. If you think about like saturated lemonade or iced tea or something, we usually would say it's saturated if it has a very strong taste to it, all right? Because there's a lot of the solute in the solvent, all right? Now, if it's actually saturated, the way to test it is if I add more solute, if I've already reached the maximum amount dissolved, any extra solute is just going to go down to the bottom. And I can sit there and try to stir it and everything like that, but it'll just eventually settle down to the bottom. You probably have seen that with like salt water, where we pour a lot of salt into the water, and we sit there and try to stir, and eventually we just can't get any more salt to dissolve. So that would mean my solution above all that stuff at the bottom is saturated. So you are saturated when no more can be dissolved. If you have an unsaturated solution, well, that just means it's not saturated, which means more can be dissolved. Okay? So again, we're talking about the solution itself, not the stuff that you're trying to add. I mean, that's part of the solution. But again, if that shows down at the bottom, these particles down at the bottom are not part of the solution. They're separate. We would almost be making a mixture now. We have a solution with a suspension almost, because the liquid is a solution, but the solid at the bottom is not part of that. But we might be asking, are you saturated or unsaturated? Okay. And again, this depends on temperature. We can manipulate the saturation point depending on the temperature. We could have a saturated solution, but we're going to see in just a moment, if I change the temperature, it might become unsaturated. Supersaturated is a unique situation. This is not something that just happens all the time, every single time. All right, it's actually pretty difficult to occur. This is where the solution has more than should be dissolved at that temperature. All right, where it turns out the solution is actually holding more solute than should be in there based on the solubility of the substance and the temperature at hand. So again, this is not something where you just add more and you're like, hey, I've gone above saturation, it's supersaturated. No, most of the time, those particles settle to the bottom and we're still just saturated. This is something that's a little tougher to do, where basically what you have to do is you have to have a solution. You basically got to heat it up. You start adding your solute, you start adding your solute, start adding your solute. All right, so you have a ton in there at a high temperature. Okay, we're going to see in a moment with increased temperature, we increase solubility. So then what happens is you remove that fire and let the temperature start going down. Well, if the temperature goes down, we should decrease our solubility. And so what should happen is we should start seeing little stuff come out of the solution. But if it's supersaturated, everything stays in the solution as the temperature goes down. All right, I have rock candy here because this is how rock candy is created. Basically, you create a supersaturated solution of sugar, and then if you just add a little bit more, the solution is basically saying, oh my gosh, no, and it basically throws all the rest of the extra sugar that's dissolved and basically helps crystallize it on a stick that already has a little bit of sugar on it. So again, saturated means no more can be dissolved. Unsaturated means that we can add more. Supersaturated, basically anything that we add afterwards, the crystals are going to get larger and larger and larger. Okay. Kind of as a side note, again, something we mentioned with ionic compounds. Solutions are conductive if there's an ionic compound dissolved. Okay, they can conduct electricity. So again, this is where we get what are called electrolyte solutions. It just means that we have an ionic compound dissolved, and then if we have some sort of conductivity meter, that the ions are able to conduct that electricity from one side to the other and possibly be able to turn the light on. So the last big thing to do in this unit for solutions is solubility curves. Okay, solubility curves basically involve, you're going to see in a moment, it's a graph showing how the solubility changes with temperature, so you might as well just move on. So this is kind of one of your standard solubility curves. Sorry, I want to see something. Yep. All right, I'll just go to that one too. So this is one of your standard solubility curves. What you basically have to pay attention to here is you can see temperatures on the x-axis, solubility is on the y. It does mention how solubility is measured in grams per 100 grams of water. Because obviously if you have more water, you can definitely dissolve more. So I mean, volume of your solvent determines how much you can dissolve. But it doesn't change the solubility ratio. Okay. But if we look at this just from taking it for what it is, I can look at basically different chemicals I'm trying to dissolve, different salts, and basically all of them except for NaCl, sodium chloride, we see that the solubility is increasing with temperature. As the temperature goes up, solubility goes up. The only kind of exception with that would be the sodium chloride. It does go up, just very, very, very little. All right. So that's kind of our first take with solubility curves. All right. Now I'm going to go to the next page because I feel like it's just easier to see it on the next page. And we'll go through some questions that you could be asked for. Okay. So this one has a lot more curves on it, but we can see all the letters a lot better, and I think it's a little bit easier to see the graph too. So, I mean, yes, a little confusing to see all the different chemicals. Just make sure when I mention a chemical, we kind of follow that particular line. We can see that we actually have ammonia right here. Its solubility goes down, so that's a unique one versus all of the other ones going up. We can see the Ce2SO43 going down. But in general, all elements, all compounds increase solubility when we increase temperature. So some questions I can ask, I could be like, which chemical is increasing solubility the most? All right. So what I'm looking at least through this graph, I mean, we might be given a temperature range, but if we look at the whole graph, we can definitely see, whoops, that's the eraser. We can definitely see that KNO3 changes dramatically from 0 up to 75 degrees or so. All right. So KNO3 definitely has one of the largest changes in solubility. Okay. We can ask which one changes the least. We already mentioned it. NaCl basically changes almost nothing. Which chemicals go down? NH3 and Ca2SO4. But what about some other questions? All right. Some other questions might be where you just have to find a data point. So I might say, how much KNO3 can be dissolved at 50 degrees Celsius? So what I would do is I'm going to 50 degrees, and I'm going up until I hit the KNO3 curve, which is right here. And then if I go over to the y-axis, I can see that 80 grams of solute, 80 grams of KNO3 can be dissolved in 100 grams of H2O. Okay? So there's an example right there. So you might just have to kind of identify a data point. I could go backwards and say, at what temperature, about what temperature does NaNO3 dissolve 120 grams? So I go from 120 over to NaNO3's curve, and I go on down to the x-axis, and I'd say maybe 56, 57 degrees Celsius. Okay? So those are kind of, again, hopefully simpler questions. We can then get to slightly more difficult questions. Some more difficult questions would be, let's say you go from, let me try to see so I can pick, yep, okay, I'm going to do that. Let's say I have a saturated solution. Oh, actually I want to go back. I'm not going to do the more difficult yet. Another good question on solubility curves that we like to ask is the solution saturated, unsaturated, or if we actually make it supersaturated? What you're going to be given here now is you're going to be given a clear data point. So let's say I'm using KNO3 again, and let's say I have 60 grams of KNO3 at 60 degrees Celsius. Will that make a saturated, unsaturated, or supersaturated solution? So I go over to 60 and I go up to 60, which would basically be right on top of the NH4Cl. But I'm looking at KNO3. I'm down here, but where is the line way above it? So I'm underneath the line of where the solution is completely saturated. The line represents, when you're on the line, you're saturated. When you're on line, okay, you have a saturated solution. When you're under the line, you're unsaturated. And then the way I usually do it, if you happen to be flying over the line, you're supersaturated. Okay? So when you're on the line, that's telling you how much you can dissolve. If you fall underneath of it, you can dissolve more. If you're above it, you're in the supersaturated state. Okay? So that would be a pretty common question. So let's just do one more at that. Let's say I have, 87 grams of NaNO3 at 20 degrees Celsius. 23, estimate about 87. Know what? I'm thinking I'm basically on the line. I have a saturated solution. Okay? Now getting to something a little bit more complicated. What if we get this question? Well, I was going to use this one before already. Let's say I have a saturated solution of KNO3 at 60 degrees Celsius. So I'm using that one, 60 degrees Celsius. And then I lower the temperature to 40 degrees Celsius. How much will precipitate? How much will come out of solution? Remember, precipitate means that's a solid coming out of the solution. So what's happening here is I have a solution that I've heated up and I've saturated it. So let's say, again, don't go crazy. Let's say it's 102 grams. We kind of can estimate the amount if it's just above the line. So I've gotten 102 grams of KNO3 dissolved at 60 degrees. But then I lower the temperature to 40. At 40 degrees, I'm going to basically say I can only get 60 grams in solution. So therefore, if I had 102 grams, and now I'm down to only 60, how much came out? How much solute precipitated? Well, all I do is subtract these two numbers. 102 minus 60 equals 42 grams. 42 grams have come out of solution. So if I'm looking at giving you basically two temperatures, you're looking at the two saturated points at those temperatures on the line, and then basically subtract the two to figure out how much came out. This can be done vice versa. I could say I have a saturated solution at 40 degrees. I now increase the temperature to 60. How much more can I add? 42 grams. So it can be used either way in terms of that question. The only other one that can come up, but I don't think it comes up too much in physical science, is making you pay attention to the y-axis where it says this is per 100 grams of water. What that means is if I have 100 grams of water, let's say I'm going to go back to the 60 degrees KNO3, I can get 60 grams of KNO3 in solution. Okay, 60 grams in solution. Well, what if I double the volume? What if I go from 100 to 200 grams of water? What that means is I can double how much I get in. So 60 times 2 is 120 grams. So that's one thing that they might ask. And I've only really seen it where they're like, I want you to double the volume, triple the volume, or half the volume. Okay? And all we do is whatever you do to the volume, you do to your solutes. Okay? So if we had to half it, if we went down to 50 grams, that means we would half 60 and only 30 grams could be dissolved. The ratio for the solubility has to remain the same. So if I increase one, I have to increase the other by the same factor. Okay? And that is pretty much it. I think that's pretty much all the questions that you can ask on solubility curves. Very popular on the EOC, so we want to take advantage of being able to do these correctly. All right? Thank you.